Alrighty, so thank you all for joining today's C-SCRIP webinar on Internet routing security. We will be recording today's webinar for future reference. So if you experience any issues with Zoom, please email us at cscrip@nti.gov. My name is Ona Springberg, and I'm joined by my colleague, Catherine Bazinski. And together we manage C-SCRIP, which is short for the Communication Supply Chain Risk Information Partnership. C-SCRIP's aim is to share supply chain risk information with trusted communication providers and suppliers. Our goal is to improve small and rural communication providers and equipment suppliers access to information about the risk to key elements in their supply chain via our website, cscrip.nti.gov, our quarterly newsletter, or through events like this. You can stay connected with us via email sign up, link in our website, which you will find in the chat shortly. And today we are fortunate to have ARIN, the American Registry for Internet Numbers, join us to provide an overview of Internet routing security. Internet routing security is a vital but often overlooked part of your organization's network security. Disruption in Internet routing can lead to loss of service, theft of data, extortion, and other malicious attacks. Therefore, implementing Resource Public Key Infrastructure, or RPKI for short, can enhance routing security for your organization's IP prefixes. Our speaker today, Brad Gorman, is a senior product owner, routing security at ARIN, and is the community resource for RPKI, Internet Routing Registry, and other similar topics that impact routing security within the ARIN region and the greater Internet ecosystem. Mr. Gorman has worked in the Internet community since the mid-1990s as a network engineer at service providers like American Online, Time Warner Cable, and Charter Communications. He's also spent 3 years at the peering coordination for VeriSign. Brad represents ARIN at other regional Internet registries in the RPKI community and the Internet Engineering Task Force and industry conferences and meetings. Before I pass it to Mr. Gorman, I wanted to go over some housekeeping rules. We'll share the slides to those who registered in the coming weeks, and we'll post the recording on today's sessions on our C-SCRIP website for future reference. Mr. Gorman's presentation will be around 45 minutes, and then we'll keep the 15 remaining minutes to tackle Q&A. We please ask that you type your questions in the Q&A function of the Zoom, and my team will compile them and will respond to them during the Q&A portion of the next webinar. So without further ado, Mr. Gorman, the floor is yours.
Thank you, Ona, and thank you everyone for attending today. Hopefully I can give you all a good understanding of what routing security is, why it's important, and how RPKI can help you. Let me go ahead and share. So as Ona said, I am the senior product owner for routing security, and my role inside of ARIN is to track and promote and get the community an understanding of why routing security is important. And then on the other side, I prioritize the projects that the community asks for and make sure that ARIN is providing the services to the member community that they ask for. So without further ado, I'm going to talk a little bit about routing security and BGP, just as a background and understanding on how it works. Then get into RPKI and the routing security and how it works and why it's important to you. I'll go into a demonstration of how RPKI will function and how it benefits users who adopt RPKI and start making statements about their resources. And then I'll go through the ARIN interface. And that's actually going to be plenty, but with the time allowed and all of the information that I'm putting out in front of you, this presentation will be made available. And there is a whole lot of supporting slides and information at the back end that is useful, and I hope you guys take advantage of it. So go ahead and get started. Now, internet routing. Well, we all know BGP is the protocol that runs the internet. And the first instance of the BGP protocol was standardized 35 years ago in 1989. None of us use that BGP anymore. We are running what it was called BGP4, which we only call BGP. And even then, that was standardized almost 20 years ago. But when BGP originally was standardized and updated, it was not it was not a secure protocol. It was meant to be easy to turn sessions up, but the idea of the secure portions of BGP weren't put in the forefront at the time that it was developed. So in the times of early internet peering, networks knew each other. People knew who was on the other side of that connection, and you would share traffic amongst one another. You trusted everyone was going to be doing the right thing, and their configurations were correct. So you could typically pick up the phone and call someone to figure out a problem if there was in fact one. And really it was a handshake deal. There was no large process to signing up a new peer. It was just, again, it was a very easy thing to turn up connectivity between two networks. Now, how did BGP enable the network we know today? Well, I've already brought it up. It made it easy to connect networks with one another. When growing out of the early days of the internet, it became a bit more sizable. We understand. We know the internet that we use is wide ranging. It's across the entire planet. We all use it, but when it scaled beyond that one-to-one, or very few people running their networks, it made it very difficult to assure that the stability of routing policy was the state of which that policy was, or how your networks were being announced and handled across the internet. And as the internet grew and it transitioned away from an information sharing platform, or might I say, in addition to being an information sharing platform, it really became a commercial platform. So what we use today, and with the internet that we use today, is in entertainment and commercial processes and connectivity to data resources and sharing of information. It really is a large environment that is widely used. It is ubiquitous, and it is part of our daily life that really we can't live without. So with that, scale leads to complexity. The first diagram that I showed you, where it had a couple networks just talking to one another, now there are more networks in between, and each of these different networks, they're autonomous systems. It's network operators that interconnect with one another, and the way that you identify yourself is with an autonomous system number, or an ASN. In this example, I'm going to keep it easy and not do numbers. I'm using letters, but pretend that's the autonomous system. So just like in the first example, there are two networks that are now sharing reachability information on across a much larger playing field than there was initially. But again, BGP is easy to use, and it was established to make it a simple process to turn up peering sessions. So one network would share information with another network, and it would just get to where it needed to be. So as things progressed, we knew that it was going to be much more difficult to make that knowledge known widespread about where you wanted to send your information to, where you were passing your network announcements to the internet, to BGP. You no longer had the option or the availability to make a broad statement to the rest of the world and say, this is what I want to do. This is what you should be seeing from me. And as time went on, there were routing security tools that came into existence. And in the early 2000s, there was the Internet Routing Registry. It was a place where people could make some of these statements about where an announcement should be originating from. And it was an open ecosystem of multiple databases, sometimes in excess of 25 databases, where people could store information in. And all of the 5 RARs, ARIN included, do run their own Internet Routing Registry. And those registries are authenticated, so the data that's in them can't be created by someone other than you, the actual resource holder. I'm jumping ahead a little bit. So those features and those capabilities are great, but over time, the data became stale. And there were other databases that were not inherently secure. You could put information about others' resources into those databases. So we had to come up as a networking community with another means to make statements that were authoritative about where your announcements should be originating, as well as a way that could be assured that no one is making statements about you, the authorized resource holder, and that your announcements are coming from, and the statements that people are saying are coming from the authorized resource holder. So this is hopefully the only page that I'm going to read word for word, and I'll try to stay away from it as well. But what is RPKI? So RPKI is a public key infrastructure. It's a resource public key infrastructure that creates a chain of certificates that follows the same structure as how the RIRs hand out IP addresses and AS numbers. The ARIN, again, is authoritative for all the resources that are in our registry that were given to us by the IANA. And any of the information that people are looking for about those resources, ARIN holds the knowledge and the responsibility of making sure the information stays correct. But with the RPKI works exactly the same way or similar in the sense that ARIN can be the only RIR that can make an authoritative statement that the resources and the information that is in an RPKI database was created by the authorized resource holder and by no one else. Now, what does RPKI give you? It gives you, the resource holder, the opportunity to make these statements about where your announcements should be coming from, which autonomous system is the proper origin for your routing announcements. And again, it uses this cryptographic chain of validation going back all the way to ARIN to say that what this data is authentic. ARIN has verified it, and you can trust it when you see statements that refer to what you're creating here. So what really does RPKI do? It establishes a level of trust that the data is authentic and coming from the authorized holder of resources. Sounds familiar, I already said it. But the first big benefit is it allows network operators a way to make better judgment on how they're going to handle a network announcements coming to them across the internet. It is network policy that is the ultimate benefit of what the RPKI data it promises to the community. It will give anyone who has peers that connect to the internet to make sure that they are making a good informed decisions on where things should be coming from and being able to compare it to an authenticated database of information. And RPKI can limit the impact of configuration errors or nefarious activity of a bad actor because the operator can go and compare against RPKI data and what they're seeing in the global internet routing table. They can stitch that information together. And when it's being used, when it's in process and in function and actually in practice, it can stop and has been known to stop large wide-scale impact or even completely obscure the fact that someone is trying to do bad things. So you might ask, why is RPKI important to me? Well, ask that question. So don't you want to make sure that your announcements of your resources are accepted by and passed along, assuring that you are the one sending it, and you want to make sure that it gets to where it needs to go and doesn't get rerouted due to somebody trying to do bad things. So when the first thing that an organization or a network that has resources, that has IP resources, does is you create an object inside of the RPKI called a ROA. It's a route origin authorization. So you make those statements about your resources, but it's not just benefiting you, it's going to benefit all of those other network operators along the way who are using this RPKI data to make these more informed decisions. And the more people who make these statements, make these ROAs, the more network operators that make decisions based on ROV data, route origin validation, and I'll get into both of those definitions a little bit more in a minute, that it helps those network operators stop the propagation of bad announcements, and other network operators don't have to worry about bad announcements coming through. It's a growing, snowball going downhill, and as it gets bigger and bigger, it gets more and more protection associated with it. Now, there have been documented cases where it's been proven to interrupt hijack attempts. There are plenty of examples that you can just search on RPKI hijack, and unfortunately, large list of things come up of instances where traffic was diverted or otherwise interrupted or disrupted. But as you read into these stories, you'll see that those who deployed an RPKI configuration, made these statements, actually had a much smaller impact, or even that there was no impact, which is really the promise of RPKI, that someone is trying to do a bad thing, but you don't even know about it. Another reason why you should be concerned and in tune to using RPKI is that a number of internet service providers are requiring you to create these ROAs before they even start announcing your routes. Now, those could be a connectivity provider or a service provider who is going to host information for you. And it could be any number of places that are going to say, okay, you want us to do this for you to pass your traffic along. You need to adopt RPKI and make statements for your resources. And the last thing is, I had mentioned the Internet Routing Registry, and it's 25 years old. And there has not been further development associated with it. But with RPKI within the standards community in the IETF, we are pushing forward with new features and new enhancements and new capabilities and new knobs that will further advance the benefits of running and using RPKI to the ultimate goal of making it impossible. Let's hope we get there, but making it extremely difficult for anybody who is trying to make nefarious actions and interrupt things, making it extremely difficult for them to do that in the future. So let me give you a little bit of an understanding of how RPKI flows through the system. So the first stage is where you, the resource holder, make the decision to sign up and start using RPKI. By doing that at ARIN or any of the RIRs, you're going to be issued a resource certificate, which is a list of all of the numbers, whether they're prefixes or autonomous system numbers, that are covered under your organization. And that will be used. That's part of that cryptographic chain that will verify the information is correct, and that ARIN has agreed and authorized a particular network organization to use those resources. So next stage is going to be where you create those ROAs. That's the key foundation of RPKI at this point. And if you don't create ROAs, there is no benefit for you or other people in the network. So then that data the act is called being fetched from the RIR databases. And there are applications that grab that and then verify based on that path of cryptography, and then caches the content that is valid. That data is then pulled by those network operators, and that RPKI and BGP information that you see in the global internet can be compared and establish what's called an RPKI validity state. And that's what's used to build policy on those networks. And, over time, overall, it enhances global routing security. So we've talked about ROAs, and I've talked about route origin validation. And here's hopefully where I can clear up some of the information of how they're different and what they do, and why they're both important. So route origin authorization, that's your ROA. Now, ROAs by themselves, by you creating a ROA, has no direct impact on your routing announcements. That's because RPKI data and BGP data are inherently different sets of data. They do not connect with one another. So you can create ROAs for your resources, and if nothing else is going on, your announcements, as you've configured on your internet connected devices, that router will not, its configuration will not change. You are just populating this third-party database with the information about where your resource announcements should be coming from. So the RPKI data is independent of the global BGP table. Now, creating a ROA doesn't mean you're now making a new announcement. As I said, you're not modifying router configurations by the act of creating an RPKI ROA. Now, it's also a case where you can create a ROA for a prefix and stating an origin of where that prefix should be coming from, even before you start announcing it. Depending on the deployment case, the examples or requirements that are put upon you by either your organization or a service provider, you may need to create these ROAs before the announcements even exist. Now, route origin validation was that act of establishing a validity state. And an RPKI validity state, simply put, is either valid, invalid, of which there are subsets, but invalid meaning it doesn't match what's in RPKI data in the BGP table, and not found, which is effectively there is no piece of information that can be compared and stitched together. And in that case, BGP just does its thing as it is today. So performing origin validation actually is a conscious effort made by a network operator. Many network operators that either connect directly, have direct internet peers, or peer with other customers inside of their organization, just by creating a ROA, you're not doing origin validation. And that's an important part that I'll get into a little bit later. Now, when that data is then taken and consciously blended together, that's where you establish this validity state. And the validity state is a clear understanding that A matches A and B matches B, but if A doesn't, if A it points to C, that's not correct, and that's invalid. And then RPKI, the way it's configured, will mark it as such, as being invalid. And then operators who are doing origin validation take that and act upon it. Now, absence of RPKI data, it isn't bad, but that means, again, a validity state cannot be established. And as I said, BGP does its thing. Now, origin validation isn't for everyone. It is suggested for organizations that have downstream customers, many downstream customers. It can be, connectivity providers that have multiple peering points with other connectivity providers regionally or globally. But that does not mean the edge network operator who doesn't have downstream customers can't perform origin validation. But typically your connectivity provider, your internet provider, is already performing origin validation and otherwise isolating you from any bad traffic that's coming away and passing your valid traffic along to them. So like I said, it's not something that you cannot do, but it really isn't required if you are an edge network, an enterprise or otherwise just, independent or, organization connected to the to otherwise yourself and upstream to the internet. So let's take a look at what happens with BGP, just the way things are running today. And we're going to move into how origin validation and the creation of ROAs benefit, the greater internet in providing routing security. So again, as in the first example that was that I showed before, there are networks that are sending data across the internet, and the traffic is getting to where it needs to go. But I've now introduced this bad actor who says, I'm going to try to hijack this traffic and say, I'm the source that it should be coming from. So they're announcing their ASN as the origin for the same prefix as network Z. And that announcement goes along a similar path, gets to the destination at the other end, and as routers do and things that are internet connected, they will then look at, hey, this is an equal cost path to get to the source of this prefix. And depending on the technology that's being used, the vendor technology, it could be the last update that comes in that becomes the right path. So in this case, that network X has successfully hijacked traffic that should be coming to and from network Z for that prefix. But here's the promise of origin validation, and let's take a look at that. So the owner of that prefix now has created a row that says the origin of 198.151.100.0 is ASC, is me. And then they've created that row, and that row is in the RPKI repository at ARIN. And anyone who performs origin validation can see that and use that information. So here's Network C, and they have opted to start doing origin validation. And let's see what happens when Network Z makes this announcement. That operator says, I've matched the data with what I'm seeing in BGP and in RPKI. It's marked as valid, so I am going to pass reachability announcements beyond me. And that network announcement makes it to the other end of the internet, so to speak. Now, if the bad actor tries to do the same thing, that network C, who is doing origin validation, says, no, I'm sorry, what I see in BGP originating from autonomous system X for this prefix does not match what I'm seeing in the RPKI data when I'm doing a comparison. That RPKI data says it should be coming from network Z. So it says there is no match, or it doesn't match, therefore this is invalid, and I'm not going to send that traffic along. So great, network C has done this. It's doing a great thing, but with a low penetration of networks that are doing origin validation, there's always another path to get that announcement to the other end. And again, we're in the same situation we were as the previous example, that bad actor, that network X, has successfully sent a route announcement that says, I'm the source for this data. And again, even though a row was created, that other path was there that was unprotected. So here we go, and let's start getting the true benefit of how origin validation is going to work. Now network C and D are both doing origin validation. And in our limited example of the internet here, network Z is going to get his traffic passed along. We've already established that. But network X now is going to get a little frustrated, because as he is trying to announce himself as the origin of a particular prefix, it's now getting stopped at network C and D, because they're going, hey, wait a minute, this does not match what we've got in place, and that we see in the RPKI based and comparing it to what's in the BGP table on the internet. we're not going to pass this information along. But in actuality, what they've done is only protected, a little bit of the left side of the screen, because all the rest of the networks that are in play here, short of the authorized network Z that should be announcing it, are listening to these bad announcements. They're carrying that traffic across the links that they have. They're not being protected by a configuration of networks that are doing origin validation, and they are now susceptible to getting multiple paths to the same announcement. And there's a possibility that, again, the bad actor has successfully performed a hijack on traffic. Now, let's get to the further development of networks that are doing or performing origin validation. Now, C, D, F, and G, those network operators are all performing origin validation. And as you see, Network X is really getting frustrated at this point. They're trying to do something bad, and nobody is passing their traffic along. So all of the attempt of hijacking traffic or passing along bad information or just otherwise causing an unstable internet, it's getting blocked. And now there is a much larger footprint that is being protected by doing this. So that is the purpose and function, the way RPKI works today, that a resource holder creates these ROAs, makes these statements about the origin of their announcement. And as operators perform origin validation, it benefits not just you, but it benefits everyone else along the path. But it is key that you create ROAs, or resource holders create ROAs and make statements about the rightful origin. Because without a ROA, it doesn't matter how many operators are performing origin validation, it's not going to, you won't get the benefit out of it. Now, I want to go into the services that ARIN provides to customers, but before you get started, you'll need a few things. You'll need IPv4, IPv6 addresses. Those addresses need to be covered by a registration services agreement. You need to be a user on the ARIN Online, to the ARIN Online portal, and your account needs to be linked to an organization that has those resources assigned to it. And your account needs to be have the privilege equivalent of an admin, tech, or a routing point of contact. Those are the only three levels of authority, so I guess, that will allow you the privilege to make RPKI configurations. And then you'll need an autonomous system number to state that is the origin. But in function, in practice, you may not be originating your prefix, like the example of somebody who's going to be hosting, or a service that is bring your own IP service. Your ROA would be created with the people who are announcing your route. If you are not announcing it from your network, it would be from someone else's network. The origin ASN is different than yours. The prefix is what is key, the key field inside of the ROA. And the origin isn't something that has to be authenticated or assigned to you. You can put whatever origin you want into the ROA. So there are three services the way RPKI works. There is hosted RPKI, delegated RPKI, and then a service that we add on to users with delegated RPKI. But hosted, again, it's recommended for most organizations, certainly getting started using RPKI, because it's the lowest lift, right? You as the resource holder just creates your ROAs, and ARIN does everything else. We do that verification that the data in your ROA is correct. We put it in a repository, and we announce that database to the internet so that people can pull that information down. The fact that more than 97%, almost 98% of ARIN users use the hosted RPKI service that's really pointing to the fact that it is the simplest and easiest path to get started. Delegated RPKI is when an organization wants to maintain the cryptographic components of the objects that they're creating. They run their own certificate authority, and they will host a database of information of the ROAs that are created for them. And the only thing that ARIN is doing for a delegated customer is when they sign up, we create that same resource certificate that we talked about, the resources that are directly assigned to them by ARIN. And then ARIN serves as what's called the trust anchor. Okay, ARIN, again, is the final authority to say these are resources within our registry. And then we confirm that a ROA created with this within this certificate authority is actually the authorized certificate authority to do it. Now, running the repository is actually the heaviest lift of all. There is a pretty stringent uptime requirement, and some organizations really don't have the people or resources or even space to run these repositories, or they just don't want to do it. And ARIN has a repository publication service. So it's kind of a mix between you get the still full control of the cryptographic components, but you don't have to run a high availability repository and making sure that it is available for the internet to download that data. And the number of organizations that run delegated RPKI certainly is a very small percentage, but of those, at least 50% of them, and the number is actually growing, do use this publication service because they don't want to get their fingers into this high availability thing to make RPKI work for them. So hosted RPKI is the way to go. So when you make the final decision, you need to plan it out. You need to figure out which deployment type of RPKI you're going to use. Strongly recommend hosted RPKI. You may have specific services that will determine how maybe you create your ROAs. An example is like a DDoS service. They may have requirements on how you announce and how you create ROAs, because they will be in the mix on how prefixes of yours will be announced. So that is one of the specific examples where you might have a criteria that you need to be important to you when you're making these decisions. ROAs show up and you create them, and they're instantly generated or very quickly generated and put inside of basically a staging pen. And every 5 minutes, the ARIN repository will regenerate with this new information and then become available to the public for use. And another key thing is that by you creating a ROA and it showing up in the ARIN repository in 5 minutes, that doesn't mean that everyone knows about this ROA right away and is taking action upon it. And the impact of a newly created ROA and knowledge of it across to the other side of the internet could take between 30 and 60 minutes before that actually happens. So I'm going to kind of go through the portal on how it works, and I'm going to go a little quickly, but I just want to show the example of how simple it is to get started and start using the ARIN tools, using the hosted RPKI, and just go through the example. So you've logged into your user dashboard on ARIN Online, and you select routing security in the left-hand nav. It will then provide you a dashboard of any of the organizations that you're attached to or associated with that routing tech or admin privileges. And then you pick an organization that you want to sign up for RPKI. So you select it, and you're presented with the choice of, do you want to do hosted or delegated RPKI? Well, in this example, I've said hosted, and we'll move along. And as soon as you've signed up, as soon as you selected hosted, you have successfully enrolled, and your resource certificate has been created, and your ready to start creating ROAs. But real quickly, in that status overview, assuming you signed up today, it would be today's date. If you selected on any of the other current certificate, you would see that information associated with it. And right now you have no ROAs that are identified. You haven't created any, but these are what exists on your certificate when you go and select the resources tab, certified resources. But again, if you go to the ROAs tab, you haven't created anything. So the ROA table is blank. So let's go ahead and select create a ROA and see how it goes. Now, this is really as simple as it gets. There are 4 fields inside of the ARIN tool that must or can be populated to create a ROA. So the first 2 are mandatory, are the origin and the prefix. You know, you have to say this prefix is coming from this autonomous system. And the next 2 fields are optional. There are the max length and a ROA name. Now, a ROA name is clearly something that's human readable. Every ROA has a extremely long key buried within it that no one can look at and say, hey, I know what this is about. But that's where the ROA name is good for. People can see it and understand. And then a max length is a variable that is a more advanced piece of where RPKI works, but you can say, make a statement of, if I have a large aggregate prefix, I want to cover resources down to a particular level. So if you have a /16 network, you can make a statement that, you know, I want the /16 all the way down to a particular smaller subset of that 16 to be covered by my ROA. So after you go to the next step, you review what's being created, and there's your origin and the prefix. The ROA name, it gives you the final chance here. And then you just go and click submit and you move forward. Now, one thing I do want to call out on this particular field or this particular table is auto renewing. Auto renewing is a feature that ARIN turned on a year ago in May, where when you create a ROA, it will not actually it will not expire. We will refresh your ROA at a date 80 days after your creation, after you select submit here, and then refresh your ROA with another 90 days worth of data or of lifespan. And there's the ROA that you created. It's down in the table. So it was successfully created. It's listed in the ROA table. And now it's time to go create more ROAs. Now, along with the web interface, we do have a RESTful API that allows you to make bulk changes where that's currently not available in the web user interface. At ARIN, we've tested with 2,000 actions and in the same call. Customers have reported making many more actions within a same call. You can add and delete in the same API call, which is currently not available in the web UI. All of those updates, if you're making 1,000 changes, they will all go in during a single repository generation cycle. So the start to finish action of the API call is validated, confirmed it's completed, and then the next 5-minute cycle, all of those changes will be pulled in and put into the repository. Like I said, so these features are not available to the ARIN Online users yet, but we're looking forward to deploying similar features. And then there are links to the pages that explain more in detail what the payload needs to look like inside of an API call, and what the output's going to be when you're completed. So there are considerations that you have to go into when you're creating ROAs, and these are actually something that I'm going to kind of pass up on because we're sort of running out of time here. But there are key components that you have to be aware of when you're creating a ROA using max length, taking into consideration the announcements that you have and how they're showing up on the internet. It's important that the order with which that your ROAs are being created, and based on whether it could or may not be impactful to routing announcements. So the steps with which you take are important, and these are, you know, best practices in the IETF community, and lessons learned from other network organizations that have done this before you. They're out there so that you don't reinvent the wheel and impact the same mistakes, or get impacted by the same mistakes that someone has already encountered. So I apologize for not going through these specific examples, but again, it'll be available to you when the slide deck is when we give it to Ona and to Catherine for distribution. And really, once you get to the point where you're ready, you've signed up, and you want to start creating ROAs, ARIN is here to help. It's sometimes it's really difficult to get your hands and get your mind wrapped around RPKI. In fact, first time I started reading up on RPKI, it was 3.5 years ago. But I, by no means, being the product owner and somebody who thinks and breathes about RPKI during the workday, do I know everything? So there's always there to ask questions. That's why we're here, and the community is very forthcoming and very open with assisting people when they have questions, so that again, you don't get impacted by things in the future. So what do I want to get you to get out of this is that routing security is a global effort, right? We all need to do our part, and the very first part that we all need to do is create ROAs for our resources. The ARIN Online interface is simple to use. I mean, there's only a few fields that you populate, and there's not a whole lot of other steps that you need to take other than reviewing and saying, create my ROA. And then the hosted RPKI service is definitely the way to go. It's not just small organizations. There are very large organizations that use hosted RPKI because they just don't want to get their hands dirty with running this repository. And certainly the point that you want to put across is following and taking note of the best practices and the standards that are put in place. And if you have more in-depth questions or specialized requirements, as I said, we're here to help. So how do you get a hold of ARIN? You can call our help desk from 7 a.m. to 7 p.m. Eastern time. From the user dashboard, when you're logged in, there is a selection for open a help desk ticket or ask ARIN. There's also a chat feature that you can use and talk to our customer service representatives. And my team has a routing security team. We have our own separate inbox where people can come and ask questions, whether it's member organizations like yourself or people from outside of the ARIN region. If they have questions, feel free to send those requests in. But it's always good to start with opening a help desk ticket or talking to our registration services team or help desk so that things can get properly tracked. There you go. I know I'm a little bit over, but and I put a lot of information out there in front of everybody, but any questions?
Yeah, thank you, Brad, for the fantastic presentation and reminding attendees that the slides will be available after the webinar. Attendees, please input the questions in the Q&A function of Zoom. And to get us started, Brad, does ARIN enforce any security measures such as multi-factor authentication on AS owners and network operators?
The answer is yes. Starting in February of 2003, we made two-factor authentication mandatory on all user accounts. So if there is no means with which that a user can log in without being challenged. If you have a user account that is long dormant, there are or accounts like this have been locked, and you will need to communicate with the ARIN help desk to get it reactivated or just take the lock off. But you cannot log in without being challenged for two-factor authentication. Now, the reason why we did lock those some accounts that had not been logged into for a very long time, and they were attached to organizations that had resources, we did not want to give an opportunity for people who wanted to get into your account and start making statements based on your resources, or, hopefully not, try to start sending your resources somewhere else to transfer them away. So yes, two-factor authentication is mandatory. And if you haven't logged in, expect to see your account is locked. Contact at the ARIN help desk.
Thank you, Brad. We have a question from Forest Hill. How long does RPKI updates take to populate globally, or can future RPKI changes be pre-scheduled for future network changes?
So there's two questions there. The first one with regards to how long does it take for everybody to know? It is variable, but it takes between 30 and 60 minutes before all of the operators who are doing origin validation start making their decisions on what they do. In practice, it's closer to 30 minutes, but again, it could take up to an hour because the internet's a big place, and every network operator doesn't inherently have that clock of 30 minutes. They can take their own time. Now, the second part of it is, forgive me if I got it wrong, but it was asking about, in the future, could you stage something ahead of time? The answer is yes, you can create a row even before you're making an announcement. There is a caveat to that's in some of those best practices, that if you have created a ROA and there's somebody who's trying to do a bad thing and they successfully spoof your ASN and they start announcing your prefixes, with an existing ROA, that announcement would be marked as valid. So yes, you can pre-stage, but there are inherent troubles in doing that, or there are pitfalls to doing that.
Thank you for that, Brad. We have another question from an anonymous attendee asking, can certificates be stolen and used by bad actors to continue to hijack routes?
So in the case of a resource certificate, the answer is no. To use RPKI at ARIN or to use RPKI, whether it's at ARIN or any of the other RARs, that cert is linked all the way back to ARIN as the trust anchor for those certs. And there are step-by-step checks between each one of them. And if by chance, and there is no chance, but if by chance someone was to get a hold of your resource certificate, that resource certificate is bound to your organization. The resources at ARIN are tied to your org ID. And inside of that resource certificate, it is, in fact, buried in the cryptographic data. It's linked to your org ID. So if someone was to grab it and try to, masquerade as you, they wouldn't be able to create a ROA, nor would they be able to, change that certificate in a way that makes them be the right person to go. Because if that chain is broken, the information will never make it into a repository, and therefore it's a non-issue. It doesn't happen. So that it's not possible to steal that resource certificate.
Understood. Thank you, Brad. And I don't see any more questions. So to wrap us up, does ARIN offer one-on-one assistance with implementing RPKI and other internet routing services?
So to a point, yes. I mean, my team is pretty small. There's 3 of us, but we do have opportunities through things like this, where we'll do webinars, or at some of the community conferences that we go to, we will have sessions where people can sit down and go through the steps, much like what I went through here today, with me and other representatives of ARIN to help answer questions along the way. Those kinds of requests really need to come in, start with an Ask ARIN ticket. And then whether it's, scheduled in a group fashion, or if it ends up coming to a specific organization, whether it would be online or in person, those are things that have to be, figured out and negotiated out with calendars of events and things like that. But opportunities and options like that do exist, but you need to ask for them on a case-by-case basis.
Fabulous. Well, thank you, Brad and ARIN, for joining today's C-SCRIP webinar. And thank the panelists for the attendees for coming today and joining us during this presentation. We'll wrap it up right now, and we'll be in touch with the attendees with the information that we know that we will be sending out afterwards. Thank you.